There we go. I unmuted myself. Baby steps, right? I'm on my fourth plague haircut. I should probably resize that chat a little bit so it's not completely covering me. I'm willing to be a little covered by chat, but the whole thing is a bit much. I'm working on my green screen thing. So I would really like if I could point outwards here, right? Like I'm cut off here, but I am severely limited in office space. So I just have this like, ah. It's terrifying. Every time I put my arm out, I lose it. I'm gonna have to work on like everything being right here that I need to point at. There's like a very definite finger. Yes, 13 to 39. Big numbers. Pretty soon I'll be able to retire. Wouldn't that be nice? Wouldn't that be nice? I don't know. If Brent can't retire, I can't retire. Yes, yes. I do need the camera further away, but as I was explaining, I am severely limited in my office space. Like, the camera is that far away from me. And I can't move back further because when my hand is right here, this is where the green screen is. Yes, I have zoom in, but zoom in's not the point. The point is I want to be able to point at things. That's half the reason I got a green screen, so I could point at things, but now I lose my arm. It just can make myself disappear. It's all terrifying. It's all terrifying. Doo-doo-doo. Oh, I got that. Yes, rub that eye. I do need a bigger room. Unfortunately, we can't move right now. If only. I rearranged my entire office. I rearranged my office like a week ago to try and get better use of the space, and it just didn't work. There's like no way with like the size of this office and where the plugs are for this to work out. So eventually when we move, things will work out eventually when we're allowed to move. To the lounge. I mean, I wish I had a lounge. Where do I get a lounge from? Point me to the lounge. Get me a lounge, and I'll go there. I would love to go to a lounge. Paint my whole room. Yes, the thing is, I have things behind me. And I'm gonna go against my better judgment. But we have a few minutes, so if I severely screw anything up, I always have time to recover. I'm gonna take off my headset, so I'm not gonna be able to talk to you. Sound is gonna go away for a second, but I'm gonna move my green screen to the side, and I'm gonna show you why I can't just paint my whole room green. Okay, so get ready. So yeah, I have things behind. I can't just paint the whole thing. Yes, that is an old Mac. It's a very old Mac. And a Dune poster. No one likes my Nagel print. The hell? Those are like the top of the '80s charts. No love for the Nagel. It's a damn shame. Oh, this thing is all screwy now. I knew I shouldn't have done that. The things I do for you people. The things I do. There we go. I've mostly recovered from my terrible judgment. But yeah, I wish I could just paint everything green, but alas. You know what? Now that you say, I might just break down and do it. Let's buy some chroma key green. Does Krylon make a chroma key green? Because it would be much easier if I could just spray paint. Just like put some tape up and pss, like the wall behind me, and then lose all of my security deposit. Good question. Who needs art on the wall? I don't know. I could add them back in the overlay, but I think you might overestimate my streaming abilities a little bit. Like right now, I'm trying to figure out how to get a preview window so I can minimize this thing, and it's not going well. Is it studio mode? What does studio mode do? Anyone want to find out? I don't want to find out. Hey, I have a zombie. Let's ask the internet. Streamlabs. Internet. What is studio mode? Why is my mouse stuck under here? Things are terrible. Streamlabs. Oh, I spelled stream wrong. Streamlabs. What? Oh, what is studio mode? Oh, that sounds dumb. You have a Streamlabs consultant. Andy Leonard, you're so professional. Who's your Streamlabs consultant? Is it anyone I know? Alright, anyway. It's apparently noon. It's Riley, my 12-year-old. Wow! What are Riley's rates? Asking for a friend. Alright. Let's minimize this. And I don't... Wait, why did you go anywhere? There we go. Alright, so I've got chat. I've got this. I think we're ready to go. I'm just gonna... I don't know. I can't see myself. Steam credit. Wow. If Riley wants, I will buy Riley Doom behind your back. I will buy Riley all the games that like parents say no to. Don't ever change. I can't change. All I have is black t-shirts. If only I had options, then I would change. All right. So working through. It's 12:01, so I might as well stop lying to people. Stop chit-chatting, like an idiot. Saying dumb things. So this is the deck that I'm working, and it is like a lot of my PowerPoint decks short, because the longer I work on presentations, the more I realize how much time I spend writing slides, and then the insufferable time suck that is trying to find the right stock art for slides. I spend so much time just like searching and being furious at stock art sites for the things that I find. Like, it's just like I can never find what I want. Like, I even type, like, no matter how literal I get with what I type in, I always get back nonsense. So I try to spend as little time as possible writing slides that require stock art, or just writing slides in general, because like I'm just never happy with them. I look at slides, like demos I can look at for years and be like, oh, it's a good demo. Slides I look at like a week later, I'm like, this is garbage. Like, I just want to start throwing matches at my computer. It's terrible. So there's a pretty stock logo thing there, right? If we could put this in full screen mode. Ooh, wow, it's so pretty. Look at that. Look at those colors. Just they're so warm and inviting, like an arcade game that's just coated in in like years of people smoking cigarettes around it. So yeah, it's index internals that matter. And then not so long ago, I discovered the ability or the option or the functionality rather in PowerPoint to remove the background from pictures. And I've been sort of enamored with it ever since I found it. But it's kind of terrible the way it works. And like I'll give you a quick example of it. I don't know how many people have ever actually used this, but when you hit remove background, it turns this awful pink. And if you stare at it for long enough trying to actually remove the background, everything that you look at for the next half hour is a terrible shade of green. Like, this is just a really, like, it's bad, right? But, like, I think, the toughest part about it is, like, really getting anything right. Like, I've spent a really long time trying to, like, adequately, ran away from it. Trying to, like, really get, like, the background behind the fingers and around the head gone. And I just couldn't get it the way I wanted it. It's a little flawed right now. Eventually, I'll figure out how to do this in a better way. And okay, I will try that website out, Surly Dev. Thank you. Remove. You know what? I'm going to click on that link now so that I have it for later. There we go. Hopefully it works. But this is an admittedly difficult image to remove the background from, just because it is. I mean, it's a lot of white, and there's like reflections on the guy's skin. Like, you can see the background is. I mean, it's a very white. I mean, behind the pink, you'll have to trust me. It's a very white background. But this is not a fun way to spend your time. But, you mark areas to keep and you mark areas to remove, and eventually you end up with something that's okay. Like, this is probably forgivable, but I like the spot over here behind the fingers bugs me, and like the spot up by his head bugs me. I might try to figure out something else, but who knows. But one of the first things that I want to make sure that, I get out of the way early is that I'm not going to do any demos that involve nonsense. Because while this is like totally fun SQL Jeopardy stuff, like, network error? You're a network error. Well, this is like totally fun, like SQL Jeopardy type stuff. It's not anything that is particularly helpful when you need to like tune indexes or like, try to like do anything that like helps with performance, right? Like anything you do that is like performance oriented, this stuff does not just like nil error. Net error. What is net error? I'm not getting any errors on my side. What errors are we getting? Could you be more specific about the errors? Are you seeing me and or not hearing me? Like, be specific. I don't know what to tell you. There was a network glitch. Okay. All right. Anyway, everyone lost me for a minute. I wonder what happened. It was Twitch. Why is Twitch always... Why is the internet constantly working against me? It's the saddest thing in the world. All right. Well, let's get back to business. Anyway, so one of the first things that I always want to get out of the way with presentations is what I'm not going to talk about, because I don't want anyone to like get their hopes up that I'm going to be like deep diving into what's on a page or what a B tree looks like or like any of that stuff. Because you know why? Because none of that at any point in my life when I've been like, hey, we need to tune a query, we need to tune an index, has been helpful to me. Yes, it's there, right? That is exactly how like like data is stored on an index, right? Like in an index, like there's pages, there are linked lists, there are slot arrays, there are 96 byte headers. You can use dbcc commands to look at this stuff, but at the end of the day, what do those dbcc commands get you? You get to see what's there, but you don't really fix anything knowing that. So one question that I love asking people, sort of generally when we're talking about indexes is like think about it. Like just put your head like in inside a database for a minute and think about what happens to data when you create an index. Like what is, like everyone says, oh, create an index, it'll help this. Create an index, it'll help that. But like what does creating an index actually do to the data? Right? Like you say create index on column A, B, C. What happens to columns A, B, and C when you create an index on them? Like what about an index helps SQL Server with queries? Like, what about an index helps queries do something with data? Twitch is having problems. Okay, well, that's my luck, right? I don't know how to do that. I don't know how to add low resolution view also. I'm sorry, Zeus Hero 111. The data gets copied, right? The data gets copied. But what happens to the data itself? What does an index do to that data aside from copy it to a brand new structure? Right? Replication, okay. But aside from like the data being in a different place, what happens to the data itself? Like, what about an index makes data easier to find? It's a good question, right? It's a good question because it's one that not a lot of people ask when they start creating indexes. So let's head over to the demos. It stands up and claps and you're looking for it. That's right. There we go. All right. So let's start working through some of these demos here. This isn't. And what I want everyone to understand is like this isn't me doing the presentation. This is me working through the material a little bit. So you're like it is partially me like doing the demos, but it is it is also like I want feedback from you. I want to know if there's something that I could add or do differently that would make this better, because I do sort of care what people think once in a while. Despite having hand and neck tattoos, I do occasionally care what people think. I do want people to have a good experience when they're staring at what is probably an ex-con talking about indexes. So the first thing that we have to think about with indexes is how they help queries find data. Right? And that's a pretty easy thing to do when we start running queries that have a where clause, right? Because where clauses are where you want the data from. Yeah. Since right now over on the post table. Now, this is a weird copy of the Stack Overflow database. This is what I call my Stack Internals database, and I really flipped the script on this one. See, most of the time when either Brent or I have made copies of Stack Overflow, we've like cut it off after a certain point, like after 2014 or 17 or something. I went the total opposite direction. This is only data for the year 2019. So this particular database will stand up against the perils of time for at least another 6 months. The 6 months this database sucks, but for now this looks like a very current database. Yeah, statistics do get created, but statistics help SQL Server make estimates, right? Right? That's what helps SQL Server figure out how many rows are going to come out of something, or how many rows we're going to find, or how many rows are distinct. But that's not really what helps SQL Server find data. Right, so right now on the post table we have an index on this column called ID, and ID is the primary key. It's a clustered index, so it's unique, and it's a very, very easy. Oops, I didn't run the query. I got all caught up talking to you. I didn't run it. There we go. SSMS is misleading sometimes, but it's a very, very easy breezy, beautiful index to find this data in. Right, we can seek right into the clustered index on posts, no problem, and we can find our data very easily in there. This is the only index right now, though, right? This is it. There's no non-clustered indexes. There's like nothing else going on this table. So if I want to find data in other ones, this index is no longer particularly helpful to me. So I'll run these both at the same time, so we kind of get like a better idea of what the difference here is. And if you notice, that first one finished pretty quickly. The second one finishes kind of less quickly. Right? So let's look at the difference. In this first one, we were able to seek into the clustered index. We were able to find stuff really nice and efficiently. And then for the second one, well, not so much. We had to scan the whole thing. We had to scan the whole thing because these columns down here in our where clause, post type ID and score, even though there's only one row of information, right? It's to say we were able to find this ID very easily from the index, but we are not able to find post type ID equals 7 and score equals 0 very easily at all. We had to scan the entire thing to find these values. Right? And when we scanned the entire thing, up here we really did seek and do like very little work to find these. If I can even see how thin that arrow is, if I can even get the mouse pointer over that arrow to figure out what happened, we can see that SQL Server actually made a really good guess on account of the utter uniqueness of that index. But down here, this is a much thicker arrow, right? Much thicker arrow. Yes, I do know how to use zoom in. I love zoom in. Zoom in is the only thing standing between society and complete collapse right now. If it weren't for zoom in, just everything would just be gone. But here we had to read, let's see, 4220678. That is a 7-digit number, so 4.2 million rows. We had to read 4.2 million rows to find that same one row. Isn't that? It's kind of funny the way that works, because like when you ask the question this way, it's a very simple, quick, easy question to ask. But when you ask the question this way, it's a much less well-performing question. It's 5.6 seconds of our lives we waited to get an answer to the same question. If we want these columns, post type ID and score, to be searchable, the number of streamers who draw over what they are highlighting with zoom in. I mean, I've been known to do that. I like to get in there, and I'm not even. I know sort of how to draw, but I only do it by accident. Like when I know you hit Control to make a square, but sometimes zoom it doesn't pick up on that, and I end up drawing like weird Charlie Brown hair on things, and it's just not fun. Right? It happens to the best of us. I've also messed up a lot, and sometimes I'll go to draw a square, and go accidentally draw squiggles instead, and I know enough to hit E to erase everything. I've screwed up enough times to learn how to fix it. So that's that. But if we want to make those columns searchable, if we want to make sure that SQL Server can find data in those columns in post type ID and score, we need to add an index on there. And now when we add an index on post type ID and score, right? If we get in there, and now we look at this query. This query is all of a sudden fast again. We're able to seek into this index, and we're able to read a very, very small number of rows again. State how to learn to use zoom in. You could. I hear that you can just throw a rock at Mark Rasinovich. Learn how to get free zoom in lessons. So this is cool, right? So we created that index, and now we can seek directly into that index, and we can find whatever we want inside of those index for those two columns, right? And that's awesome, right? That's a nice, efficient one-row seek. But what happens if we run this? Things will change a little bit here. We'll still be able to seek into this index to find things, but we're seeking to a whole lot more rows now, right? So if we look at this, we still read, for this top query, we read one row, and we seeked to one row. But in this one here, we're seeking to like 1.2 million rows. Yes, just the tips. You people are irascible. I can't trust you with anything. This is what's going to make my chat go from a nice, like, steady PG rating to PG-13. I'm not going to have any of the cool. I'm not going to be able to influence a whole like generation of kids who are just so thirsty to learn about databases that they come from me. I should just name that. Can I rename it like AOL Teen Chat? Can I change the name of my stream now? Because I feel like that's the only way to go. It's the only thing that's going to get me back. I'm gonna have to let you start like running macros and all that other fun stuff. Chat flutters, drawing pornographic Pokemons in here, whatever else you kids are into. But I guess the point over here was that sometimes a seek is great. A seek finds you one row pretty quickly, or a seek finds you a pretty small number of rows pretty quickly. Other times you get this seek that returns a whole lot of rows, and it's just not as seeky, right? It's just not as kind of cool and fun and sexy. It's not like that. Like, wow, we did a quick seek and we found that row really easily. It was like, wow, we did a seek and we found a million rows. Okay, it's a little bit less compelling. But the point is that a lot of times when people are talking about indexes, right, when they're talking about how to create indexes, like the best way to create indexes, like they'll always say, well, just put the most selective column first in the index. It's whatever's the most selective. And like that's not like terrible advice. But the point is that like the way data is these days, not a lot of it is always selective. And this kind of like relates to why a lot of people run into parameter sniffing issues. A lot of people run into, like just big surprises with parameter sniffing because they're like, oh, I put this column first. It's really selective. I'm like, well, let's think about it, because let's look at post type IDs. Some of these are very selective. There's only 1.7, there's 12 6s, there's 2300 4s and 5s, but some of these post type IDs are not selective at all. There is no selectivity here. This is some of the least selective data that you can possibly find. This is nothing select. Like if you find all the ones, big deal. You still found like half the table. If you find all the twos, big deal. You still find like half the table. This is it in here. So post type ID is only selective sometimes. Like, well, it's an okay rule of thumb to say, if you have a unique column or if you have a pretty selective column that will always be pretty selective, good for you. But not a lot of people have that. Same thing goes for scores. If you find zeros, you found like half the table. If you find ones or twos, you still find a pretty good chunk of rows. And this is just the top 10 scores. This isn't by all means all of the scores because there's just too many to go look at. But there's just a lot of scores in there. And if we look at creation date, well, creation date is pretty unique, but, not a lot of people search dates by like a simple equality. A lot of the times when people search dates, it's ranges. And if I know one thing about end users, they're like the worst. End users are the worst collection of people in the world. End users will seek in a range, right, for dates, and they'll never know what range they really want. And so they'll always like pick the biggest range. It's like, oh, well, when's the start of time and when's the end of time? We'll just go between those. So there's like how selective data is doesn't just depend on what's in the column. It depends on how users use that data too. Selectivity isn't just based on how many occurrences you can find. It's how people are going to search across some span of that data. Like say I wanted to find scores between like 1 and 6, I would still find a whole lot of rows. Selectivity isn't always just about what's there for a single value, but users aren't using things for a direct equality. Nothing is really selective. They can pick any range they want. It's like pick a number between 1 and 1,000,000. You have a million unique values. You have a million very selective values, but you still have a million values. It's like selectivity isn't just about what's there. Yes, you forgot your 420s though. There are 420 69s. Silly dev. You should be silly dev, not surly dev. Quite ridiculous. So the big thing that indexes do that helps SQL Server find data in them, help SQL Server locate data in them. I mean, statistics are great. They tell SQL Server about how many rows they're going to find. But what indexes do, remember that statistics describe data, right? Statistics are that histogram where SQL writes everything down about what it thinks it knows, like information that it's collected about the data. The quality of that information is going to depend, of course, on how much of an investigation you let SQL Server do, right? You could pick a very low sample size and get an okay one, or you could pick a high one and it could take a lot longer and you could get a better idea of what's in there. But indexes hold the data, right? All that data is in the index, and it's in that index in an order, right? And like putting the data in order is really what helps SQL Server locate it efficiently. Right? That's it, that the data is in order. But the kind of annoying thing about at least row store indexes is that when you create non-clustered indexes, every column in that non-clustered index is a dependency. And if you kind of like not going from left to right, but if you go from right to left, every column in the key of the index from here working your way over is dependent on the column before it until you get to the leading key column. And I'll explain what that means here. So if we have a very selective score, right, remember our index is just on post type ID and score. Let's say we just have a very selective score, right? We still have to scan this index, right? Even though this only returns 975 rows, we need to scan to find all of them. We need to read the entire index to locate those, because score could be anywhere in the index. By anywhere, I of course mean that the score column is not sorted independently in a way that helps SQL Server find data in there. So if I select the top 5,000 rows ordered by score, we need to sort that data. We need to physically take that data from this index and put it in the order that we want it in. SQL Server has to break out its tiny little baby hands and start shuffling those pages around in memory, and we end up with this sort operator. This sort operator is going to sort all of the rows that it finds here until it finds the top 5,000. Right? It's going to work on that. And I'm simplifying a bit, but in a nutshell, that's what's going to go down. The post type ID column, though, this one is in order, right? So if I run these two queries together, we can see the difference in the execution plans, right? We can see the difference here is that in this one, we have a sort because we needed to baby hand the pages. And in this one, we don't have a sort. There is no sorting of data in here. Having an index that leads with post type ID makes sorting by post type ID free as long as we use that index. And if we order by post type ID first, then we can order by score for free too. So if I run this query, we'll have that same query that we saw before. There's no need for SQL Server to go in and physically sort that data because we ordered by post type ID and score. So going from left to right across the key, this is where those dependencies start to kick in. The order of score is going to depend on the order of post type ID. If we had columns going further over to the right in the key of the index, then whatever column came after score would depend on the order of score, and so on. Then this is something that wasn't obvious to me when I started designing indexes and tuning indexes. Like the whole ordering thing, it wasn't the first thing that occurred to me. I would look at what queries that I had written before and indexes that I created before, and I was like, oh well, the where clause kind of helps SQL Server seek to things, so that seems like a good idea. And then if I'm joining the tables, I might say, well, we have a join column over here. Putting an index on a join column is a pretty non-controversial thing to do in a database. So there were all sorts of things that I understood about what columns needed to go where in order to help SQL Server, but I didn't really fully mentally grasp why they helped. And what's really cool about non-clustered indexes, at least I think what's cool about non-clustered indexes, is that they inherit the clustered index key. So if we wanted to select the top 5,000 rows and then order by post type ID and score and then the clustered index, then that would be free too. There's no need for SQL Server to go in and sort data here. There are no baby hands needed for this query. And we can use what we know about indexes that look like that to our advantage. So when you have an equality predicate, right, say where post type ID equals 4, and we want to order by score and then ID, and we use that when we have to use the index, of course. So we don't use our index, then it just doesn't help us sort anything, unfortunately. It's not like statistics where SQL Server can use whatever statistics it wants, and then it can use statistics from a completely different object, different index, different system statistics. It can use those to guess about how many rows, but unless SQL Server uses the index that we care about, well, we can't just use the order of another index to help us, unfortunately. I mean, we could if SQL Server used the index in the execution, but you get what I mean. If it's not in there, it's not in there. It's not going to help us. But here we have a where clause where we're searching where post type ID equals 4. We can order by score and ID for free. You can see if we look at this execution plan, there is no sort in here. There is just a seek. Right? We're asking for the data in order, but since the data is returned in order for post type ID, we only have one post type ID coming out, then all of the data for post type ID 4, right, that dependency, where score depends on post type ID, score is absolutely in order after post type ID equals 4. It's a little bit misleading because it's all zeros, but I promise you that it's actually in order. And the same thing is true if we put an equality on score. So if we search where post type ID equals 4 and score equals 0, we can order by ID for free too. Right? There is absolutely no need for SQL Server to, oops, that could have gone better. There's no need for SQL Server to baby hand this data, right? There's no need for it because it's in order. The one thing that's a problem, though, is inequalities. And inequalities, because SQL Server is not so bright. If I order by ID then score, then I will have to sort, because ID, we'll talk about it in a minute, but the way that SQL Server orders the columns in the index, yes, ID is dependent on using score. The way that SQL Server adds the clustered index key columns to the index, unless you specifically define the index differently, like if I created the index on post type ID, and then score, then it would be smack in the middle. But since I didn't explicitly define where I wanted it, it just kind of tacks it onto the end of the key columns. But yeah, ID is dependent on score. But inequalities are not as helpful with sorting data. So like we know, looking at the data having looked at the data in the table, we don't have a post type ID that's less than 1. But if I run this query and I say, give me where post type ID is less than or equal to 1, over here, SQL Server now is not sure about things. Not so sure about things. We wonder why. Well, I used to think that constraints were awesome, and that constraints were very smart, and that if you just cared about your data, if you loved your data enough, if you really got in there and you made the most of your data, you added foreign keys and constraints, and you told SQL Server exactly what was going on, that you would get much better execution plans, and like SQL Server be able to figure some stuff out. So when I was first going through this, I was like, oh well, I'll just tell SQL Server that all the post type IDs are greater than 0. Because telling SQL Server that they're greater than 0 should help it infer that nothing can be less than 1. We only have an equal 1 here. So I created my constraint, and I was excited about how quickly it got added. Right, it's a very promising thing. It only took a second to do. It's nice, but it didn't help the execution plan at all. I still have to sort that data. SQL Server is not so bright about check constraints with data types. Now, the reason for that is that SQL Server thinks that SQL Server doesn't. There's no good way to say it. SQL Server doesn't fully grasp. Shouldn't I also rebuild statistics? No, because the data hasn't changed. Like what data has changed in here that would, since I created the index, that would help with rebuilding statistics would help with. Like statistics, like updating statistics is very helpful when you modify data in the table. But if the data in the table hasn't changed, then what's the point of updating statistics? SQL Server is not going to get anything new from that. But the only the point with constraints though is that SQL Server is just not very smart about integer data types. It doesn't fully grasp that integers are whole numbers. So it thinks that it's possible that you could hit like 0.1 or 0.8 or 0.9 along the way. But if you change the constraint a little bit, I already dropped that one off. At least I think I did. Maybe I did. Who knows? But if you create the constraint to be greater than or equal to 1, all of a sudden SQL Server can figure some things out. It's like, oh yeah, I get it now. Now I understand. Now I understand that we don't need to order data here. But what sucks, what's really bad is that if we change this to be less than 2, all of a sudden SQL Server loses its mind again. SQL Server goes back to thinking that it might hit like 1.2 or 1.7 or some other number along the way, and that it can no longer quite grasp things. Yeah, crazy. SQL Server is dumb. You can quote me. I'm recording this, so I'll quote myself on that. SQL Server is pretty dumb sometimes. Well, let's switch gears a little bit though. Let's talk about another, what I think is interesting piece of SQL Server internals, and that's lookups. I like lookups. I think lookups get a bad rap because of parameter sniffing, but lookups in general are pretty helpful, because with lookups we don't have to create gigantic, awful, very wide indexes that every query just sort of pounds away on when it writes data into the table. It's a nice way to just say, SQL Server, I want to help you find stuff, but I need to show people a lot of stuff, and maybe I don't want to have all that stuff I want to show people in this index. Maybe I just don't want to do it. I'm just not interested in it. So this is why, like I was talking about the ordering thing, and I showed you that you can order the clustered index column by you can order the clustered index column alongside non-clustered index columns, and this is like part of the This is part of the presentation that I might try to reorder a little bit down the line, because this does kind of like jump in out of nowhere. This is like an interesting thing that I want to show people, but I don't know that it fits in great, like jumping from here to here, because it's like in this part I go and I go and show you about the ordering of the clustered index column, right? Because I can, like, how you can do score and ID. If you do post type ID equals 4, you can do post type equals 4 and score equals 0 and then order by ID. But this sort of like jumps around a little bit. So I might put this either before the ordering stuff or after the ordering stuff. It does kind of complement the ordering stuff because we are doing the order by thing here, but I think I need to move this a little bit. I think I need to like put that in a different spot in the presentation. I need to work on that part. Sometimes this stuff doesn't jump out at you until you read it out loud in front of people and you think, where would that go? But let's talk about lookups. Let's figure out why SQL Server would go ahead and, yeah, it really is. It's like practicing. Ooh, the ASCII art I get from this website. Let me get over there. And I will paste that into chat. And this is the actual the font that I use when I do this. So this is the ANSI Shadow one, and I like it quite a bit. There's a regular ANSI one that's this without like the sort of 3D lines on the stuff, which looks okay, but it's a little flat looking. Kind of like a weird Metro theme thing. I like this one because it's, I don't know, it just looks older. I don't know. It reminds me of like seeing old like computer ASCII art and being like, who the hell had time to figure that out? Who knows where these double lines are and that there are many of them. You can like do these things with them. It's nuts out there. So let's talk about lookups. First off is in this query, right? We're expanding this query a little bit. We have two things going on in here, right? We have this first thing where we're selecting a column that's not in our index, right? Because the creation date, while it is in the clustered index, it is not a clustered index key column. Neither is this column owner user ID down here. Neither one of these are clustered index key columns. They're all in the clustered index, but they're in the clustered index sort of in the way that, you know, leaf level columns are in non-clustered indexes, included columns are in non-clustered indexes. They're there, but they're not really there in a helpful order where, like, you know, you can search into them efficiently. So let's run this and let's look at what the query plan will now have. A lovely, wonderful, thoughtful, perfectly executed key lookup in it. If you look at the key lookup, a lot of people don't really understand what they see when they look at one. There is some decoding that you have to do with a key lookup, right? There's some stuff about key lookups that maybe isn't totally obvious. So there are what I call, like, you know, depending on what the lookup is doing, there are 3 or 4 main parts of it. You'll have a predicate. So like if you are searching for a column in your where clause that is not part of the non-clustered index that you use to find other stuff, then you could have a predicate within your key lookup. Now, these are the ones that I usually like to fix because they usually signal that there's like an incomplete index on the table. It's just like, oh yeah, if we just had this column in the index, we could find data more efficiently. We could narrow down the number of rows that we need to get to way more efficiently. The other thing that you might have in a key lookup is the output list. And the output list, it may also have columns that are in the predicate. Like if I had owner user ID in the select listed as well, it would also show up in the output list. But output list is just columns that you're selecting. All right, it's just only stuff that you like. It's just the window dressing, the stuff you want to show people when the query finishes. And then the bottom part down here, I'm going to clear those out first. The bottom part down here on seek predicates. This is the relationship between the non-clustered index and the clustered index. And this is going to be the clustered index key column or columns, depending on if you have that particular fetish where you like multi-key clustered indexes. I don't have that, but if you do, that's okay. I wouldn't want you to leave because of that. Customer animations. Custom animations. I wonder what custom animations I'm gonna get. I hope they're all kill cams of me dying in Modern Warfare. That's what I hope. Can they be that? That would be fun. So yeah, so we have the seek predicate, which is the relationship, and we can see the way that that relationship is, sort of established between the two indexes, right? We have this nested loops join. Right? There's a lot of people will look at a nested loops join between these two things and not really think too much about the fact that we really are kind of doing a self join here. Right? We're taking this table and joining it to itself on the clustered index key column or columns, if you're into that sort of thing. But that's really what it is. Now, if we run the query written slightly differently, so like this query, we just wrote what we wanted, and we got that we got the query plan back with the key lookup in it. And this one here, we're going to switch things up a little bit. We're going to join the table to itself on that clustered index key column. We're going to have everything else be the exact same, right? This is like P2, like creation date is going to come from the self join, right? We have post as P2 and owner user ID down here. So in other words, the stuff that ended up being on the lookup side of that top query, we're just going to put in the self join part of this query, just expressed a little bit differently. And we're going to get very, very similar execution plans back. So a key lookup, like really, under the covers, a key lookup is just a self join between a non-clustered index and the clustered index. So up here we have almost the exact same thing, except this one is called the key lookup, and this one is just a clustered index seek. But we still have that nested loops join that brings them together. And that nested loops join is like, if we look at this side of if we look at the clustered index seek, it's going to be identical to the key lookup, right? We have the predicate. We have, oops, I didn't go down far enough. Story of my life. So we have the predicate. We have the output, and we have the seek predicate on the clustered index key column. So really, in reality, literally, not figuratively, like the most literal sense of the word, a key lookup is just a self join. And having that clustered index key column in non-clustered indexes helps us do that. But there's a little bit of trickery about where clustered index key columns end up. Excuse me. Depending on how you define your indexes. So I'm going to create two indexes. I'm going to create one unique non-clustered index and one non-unique non-clustered index. So this unique one is going to be called Debbie Harry, and this non-unique one is going to be called Debbie Gibson. I'm not throwing any shade in there. Ronald says, there's a different I.O. No, there's no difference in I.O. They all do the exact same thing. But not throwing any shade at Debbie Gibson. She was just she's just the second Debbie that I think of. She is my second Debbie. Debbie Harry will always be my first Debbie. Except there was this one Debbie who used to live up the street from me who I had a crush on, who I probably knew of before Debbie Harry, but I don't think she'd want her name in this presentation. So, not that I think Debbie Harry or Debbie Gibson wants her name in this presentation, but I don't know. Who knows? Maybe they're both old enough that they'd be on board. Maybe they would. I don't know. But let's take a look at how SQL Server treats unique versus non-unique, non-clustered indexes. So this query up here is going to use Debbie Harry. She's our unique non-clustered index, right? So I'm telling SQL Server that I want you to use this one, and this one down here, or rather this predicate down here, ID equals 348. Why are you yikesing me? You're a human, yikes. So this one down here, 3848, whatever. If we run these two queries together, they're both going to do the exact same thing. Just look for different indexes, or just use different indexes to get data from. So this one down here, the non-unique one's going to use Debbie Gibson, and if we run these, they will have just slight differences. Actually, there's two funny things about these execution plans, and I'm going to try something brave. I'm going to try scratching the top of my foot because it's driving me insane while I'm on camera. And it's amazing that I didn't fall over because I am one of the least coordinated people in the entire planet. On the entire planet. I'm also one of the least eloquentest people on the entire planet. It's terrible. No one should ever let me speak in public. So these two query plans are going to have slight differences in them. This top one up here, we are going to have what is known as a residual predicate on the ID column. This bottom one down here, we are going to have two seek predicates, right? These are the key of our non-clustered index. But when we talk about clustered index key columns being in non-clustered indexes, well, where they end up is quite clever. So the predicate up here means that SQL this effectively this column was like, what was the word you used for the predicate? I don't remember now. That was 30 seconds ago. I'm a human goldfish. But if we have it here, we have a residual predicate right here on the ID column, right? And that's to evaluate this right here. But on the in the bottom query, this is where things get exciting. This is where Debbie Gibson really starts to shine, is that we don't have that residual predicate up at the top. All right, that is blank. Seek. They both seek. Look, there's a seek right here. I mean, I don't know, right there. Index seek. All right, there you go. Index seek. There we go. They both do seeks, but this one up here has, oops, I highlighted the wrong part. Haha, there we go. This one up here has the residual predicate on ID, and this seek down here, we just have all three predicates within the seek. We can see the scalar operator on the ID column here, and we can see the ID column right here. All right. So SQL Server, when we create unique clustered indexes, the clustered index key column sort of gets shuffled off to like where included columns are in the non-clustered index. When we have a non-unique non-clustered index, well, it's like in the key of the index. So that is a slight difference, and it's an interesting difference. I don't know if it's the biggest deal in the world. I think it's interesting. I think it's something that people should know about. I don't know that it's going to solve the biggest performance problems in the world. So I'm a little bit on the fence about keeping this demo in here. I like it. I think it's interesting. But at the same time, like, do we solve big performance problems with something like this? I don't know. I don't know if we do. I think it's good to know, but I don't know that we're solving big problems with that. I might get rid of this, and I might get rid of this demo. As much as I love my Debbies, I might have to break up with them. You let me know though. You have the heckler's veto in chat. You can say, Eric, that's stupid. Eric, that's not going to help me. Resigable. That's because I speak like I have, I don't know, like a bowling ball in my mouth. All right. Let's talk a little bit about joins, because like sort of getting into what I was saying earlier about like when I first started trying to solve performance problems, when I first started to really trying to tune queries and understand things, and I would read endlessly. I would read blog posts, books, like you name it. I read everything in the world. Brent was always wrong. I don't know, he probably left hours ago, but no, I'm kidding. But yeah, so like I would read everything in the world that I could about like index stuff. And I would always find myself when I was creating indexes and be like, well, I have this query and it's got a join, it's got a where clause. What should I prioritize in the index? If I want this query to be as fast as possible, how do I design an index to help a where clause and a join? How do I do that? So just to set the stage a little bit, I'm going to join the comments table to the votes table on these ID columns. Now, in both of these tables, the ID column is the primary key and the clustered index. Craig Friedman. Oh, Eric, you are great. Thank you. Thank you. I appreciate it. Craig Friedman is amazing. I wish I had discovered Craig Friedman earlier in my career. I didn't discover Craig Friedman until I think he was linked in like a Paul White post that I read, like, I don't know, at some point later. And then I went back through his archives, on his blog archives, and I was reading through stuff, and I was like, oh my god. And what's crazy about Craig Friedman's blog, I've gotten one email response from Craig Friedman in my entire life, but what's crazy about Craig Friedman's blog is that the stuff he was writing about in the early to mid 2000s is stuff that is still a problem today. It's still interesting that it's still exactly how things work today. I'm sorry. Which part was a weird flex? You're gonna have to be more specific. That I got one email from Craig Friedman. It wasn't a nice email. You basically call me an idiot. It's not a weird flex. There's zero flex. This is like in cartoons when a cartoon character flexes and their arm droops. at the bicep. That's what that flex was. It was an anti-flex. It was I emailed. It was something about eager index spools and why they can't be parallelized. Why they actually can't like read from why I can read data in parallel, and I think there was another question about why we don't get a missing index request when SQL Server uses an eager index spool, and it was a frosty reception. I don't blame him, but shut up, Craig. But it was a frosty reception out there. You can tell New York is starting to come back to life because all of a sudden I have traffic outside again. I have awful traffic and I have loud sounds again. For months it was silent out there. There was nothing, and now things are slowly creeping back, and people are back to being jerks. But what I wanted to point out, in this demo is that not every type of join, right? Like not every type of join like will give you the plan that you're quite after, just because you have an index. So we've talked a little bit about where clauses and how when we have like an index and it matches our where clause, we can kind of seek into that index in different ways. This is an equality too, right? Where the ID column from the comments table equals the ID column on the votes table. And these are, again, both the primary key and clustered index of both of these tables, these ID columns. Of course they are, because they're called ID. If you have a column called ID and it's not the primary key clustered index, I don't know, you probably get like I don't know, sent like Judge Dredd style sent out into the desert from the database community. But if I run this query and look at the execution plan, and it'll roll on in. This will take a second because I think I dropped clean buffers at some point. So it makes it like extra exciting, right? Because you're like, oh man, this query is running a long time. Must be doing a lot of work. It's really not doing all that much work. But even though we have indexes that are, I mean, not only do they lead, they are solely on these ID columns, we still scan both of them. We still scan both of them with a hash join because there's nothing for us to seek on. If we got a nested loops join, sure, we could totally like seek into the index on the inner side. We could totally seek in over here. We could probably even seek over here too, but we would have to read the entire index. But just having an index on join columns doesn't mean you're going to get a seek. A lot of people have that this weird I don't know, like overindulgence and what the seek versus scan and how great seeks are and all this other stuff. But really, when you think about it, if you have to read the whole table anyway, there's no value in a scan or in a seek over a scan. This is a slightly more realistic join though. If in these columns, these post ID columns right now, they don't have any indexes on them. We can't create unique indexes because a post could have multiple votes and a post can have multiple comments. So we could really only create non-clustered indexes to help this query. Right, so let's just run this. And while we run this, let's ask ourselves, how many of us have queries that just join two tables together but don't have a where clause on it? I know there might be some out there, but just sort of in general, especially for OLTP workloads, it's pretty rare to not have a where clause in a query. And I mean, there are some very special past clients who have definitely not had where clauses, but that's a different story. And this is just sort of like even entity framework developers are pretty hip to where clauses, which good job, entity framework developers. You're really coming along out there. You're really going out and getting it. But if you look at this execution plan, we're still going to see two scans. Now, granted, these scans are probably a little bit more reasonable because we don't have indexes on these on the post ID columns here, but again, not terribly realistic. So let's add a where clause into the mix, and to keep things really simple, just to make sure that I'm not like overlapping too much. The only table that I'm going to put in the where clause is the votes table. So I'm going to be searching where vote type ID equals 2, and where this creation date column just basically gives us the last 6 months of data. I know it says month 5 in there. It's because the dates cut off kind of in December 2019. So if I want 6 months of data, I really do need to go to the 5. So shh, don't tell anyone. It's a dirty secret of databases. No data is reliable or accurate. It all sucks. So let's run this. And this is a more realistic join. We're joining the tables together on post type ID. We're looking for vote type ID equals 2, and we're basically looking for 6 months of data in the creation date column. Cool. SQL Server wants an index. SQL Server is asking for an index. SQL Server is like, hey, I think I know how to design indexes. I am probably several $billion piece of enterprise software. I've been designed by the finest PhD students that money can buy. And I think I know how to make indexes. And it's okay. It's like an okay index. I mean, it's right about this part, right? It's right about vote type ID and creation date. Cool. This part is smart. This part I'm a little bit iffy on, and this is something that when I was first getting started with all this fun stuff. When I was first getting started with query and index tuning, I would always look at these missing index requests and be like, why would you want to put the column joining on in the includes? I never quite understood that, and it was always strange to me. Forrest asks if I'm using batch mode on row store. Yes, this is SQL Server 2019, but do you have a more specific question, Mr. Forrest? Mr. Forrest. So, what if we just index that comments table, right? What if we just put an index on post ID from the comments table? I mean, we could do that. It's not a bad idea, right? Again, very, very uncontroversial opinion here. Index your join keys, right? So, since we don't have any where clause on the comments table, we could just throw an index on post type ID, and that seems pretty okay to me. But it still doesn't change that scan to a seek, right? We still scan the entire index, and we still read absolutely everything from that index out into the hash join, right? We still read everything out over here, right? We read the entire thing because we don't have any filtering on the comments table. There's nothing for us to filter out if we used there's nothing for us to filter out, period. There's nothing in the where clause that says I need to find this specifically in the comments table. So we still get a hash join there. And I want to show you something kind of funny. I mean, this definitely ties into indexes and the whole ordering thing. Because if we add a merge join hint to this query, right? So I'm going to tell SQL Server here that I want a merge join. I don't want a merge join because it's better. And I don't want a merge join because it's going to prove some point about just how fantastic and amazing merge joins are. It's not. What I want to show you just about merge joins is sometimes you might be looking at an execution plan and you might see a sort in there, and you might say to yourself, I didn't ask for data in order at all. SQL Server, why are you sorting data? When you see plans like that, you might see like a stream aggregate or a merge join, and those are operators that expect ordered input going into them, right? They expect the data that shows up there to be in the order that it needs to be in so that they can stream on edge, so the merge join can sort of do that nice little data zipper trick, or I don't know. So here's a good question. Should the zipper go up or down on that? Probably up, because that brings it together. Down be like unjoining, right? Be like a disjoin. Be like whatever MongoDB does. It's disjoin things. But if we look at the query plan for this, we'll see what I'm talking about. Right here, SQL Server says, oh, you want a merge join? Guess what, pal? We're going to sort some data for you. All right, we're going to take all this data and put it in order, and you're going to have to just deal with it and wait for that. All right, so that's one kind of interesting thing. So this is sorts of plenty. To the right. To the right what? To the right. This to the right? My arm gets chopped off if I do this to the right, Forrest. Whack-a-mole. So let's create this index. Vote type ID, creation date, post type, and include post type ID, just like SQL Server wanted. All right, this is what SQL Server wanted. This was SQL Server's big foray into query and index tuning. It was like, oh, we got this. Don't worry about it. I'm gonna dunk on the other team. Dunking on Oracle right now. Dunking on Postgres. We got these index requests down. Forget it. Got nothing on us. So we do okay here, right? We still seek here, but we still hash join over here. Right? And now we have a new missing index request. Now SQL Server is like, I changed my mind. Hold on. Time delay. Zipper going to the right. Hello, future. Zipper going to the right. Well, I think it should go to the left. Right to left. Zippering on it. Yeah. If it goes left to right, then that'd be unzippering, right? I don't know. Forrest makes a lot of GIFs, so I'm just going to assume he's right about everything. But looking at this, okay, so we get now SQL Server's changed its mind completely. It's like, oh, no, post type ID shouldn't be an included column. Post type ID should be in the key of the index, way over here. Gosh darn it. Why aren't you in? Why did some idiot create an index where post type ID is not in the front? Well, let's keep track of things a little bit here. So we have an index seek, all right? We're seeking into our name of missing index sysname because I just don't care that much. What would be the point of naming this thing? So we were able to seek into this index, and when we seek into this index, come on, tooltip, be my friend. There we go. We have our seek predicates, right? And those are exactly the things that we were looking for in the where clause. We didn't seek to the join key. Of course, we can't seek to the join key because it's an included column, but we can output the join key, and then we can use that in the join, which is fine. But let's see what SQL Server is up to now. So SQL Server wanted post type ID, vote type ID, and then creation date. All right. So did I? I did. Sweet. I even remember to put the drop existing syntax in there. True mark of a professional. I didn't read the index script, and I got very confused for a second, but I put it in there. Someday I'll thank future me about that. All right, so now we have the other index that SQL Server wanted. Right? If we create this one, or rather, if we run the query with this one, we'll get a totally different execution plan. Welcome to SQL Server 2019. Welcome to the future. You have arrived. You have seen it, and we have this kind of funny-looking execution plan. We have an adaptive join. I mean, has anyone actually seen these in production? It's an interesting question. Probably not. But we have an index scan up here, right on comments table, which is what we've always had because there's no where clause there's no where clause on the comments table. We could no where clause where we could use to filter out data from the comments table. But this one down here, we used to have an index seek, but now we have an index scan. So we've gone back to reading every single row in this index. We can no longer seek to the rows that we care about, and we still end up with a hash join. That is a strange Pokemon. It is a very strange Pokemon, right? But we can see here, the actual join type was a hash match join. Seen an adaptive join once, yeah? So shortly before you took an arrow to the knee. But we can see that we ended up doing a hash join here. Right? So we ended up doing a hash join anyway. Regardless, like when SQL Server was just like, I don't care if you're the first column or the last column. Here we're doing a hash join. So when I was talking about, sort of tuning indexes to like figure out like sort order, right? So when we were going across the index, we were like, okay, if we have, this post type ID column first in the index, we can easily seek to data in it that's an equality, right? Very easily do that. And then whatever column is next in the index will be in order dependent on the column before it. So I thought a really good idea for this query would be to put post type ID second in the index, right? So we have vote type ID first, which is our equality predicate, right? That's going to be first. Oops, I got overzealous with the highlighting. So vote type ID equals 2 is here, and that's first in the index. And then our join column is going to be second in the index. That's what we're joining on. And then this inequality predicate, this creation date index, that's going to be third in the index, right? So creation date is going to be in order dependent on post ID, and post ID is going to be in order dependent on vote type ID. And when we do that, we get an adaptive join again. We have our seek back here though, right? So this got a little bit more interesting. Now we're able to seek on vote type ID. Right? We're able to find data over here. And then we have up here, we're still doing a hash join though. Why? Doesn't really matter a whole lot for this one. But what I want to show you, going back to that example with the merge join, right? I'm going to go look at our merge join again. And this is where things are going to be more interesting. Because remember in that first merge join plan, we had a sort. Right? We had to sort data to get it in the order we wanted. And now we don't. Right? There's no sorting going on here. So if you have execution plans where you see merge joins and you see a great big sort in them, one way to take care of that is by changing your indexes a little bit. So the reason why post type ID is now in a usable order is because we have an equality on vote type ID. So we have vote type ID, right, in the index. Vote type ID is all nicely sorted from 1 to whatever the highest vote type ID is. And then within any range of duplicates, post type ID is in order for all those. Right? So they have a pretty nice trick to, sort of alleviate some of the weird stresses and strains that go on in execution plans with sorts. Now, we've talked a bit about reads, right? We've talked about how SQL Server can use indexes to help read data. Right, help find data in indexes, join tables together, all that kind of fun stuff. Let's talk a little bit about locking, because locking is, until SQL Server, until Microsoft does the right thing, until Microsoft does the just thing, and starts using an optimistic isolation level by default, we are going to have to deal with locks that we wouldn't normally have to deal with. We're going to have to deal with an undue amount of pain in locks with locking. And this is stuff that I see working with clients all the time. They're like, Eric, we have a blocking problem. We have a locking problem. Yeah, I know. Change the default configuration. It's crazy. What will ever happen? All those people who have just to write queues in databases, like gigantic. I'm going to keep it PG. I don't want to lose my PG-13 rating. I don't want to lose it. So I'm going to keep it. Those people who I disagree with vehemently, who write queues in databases, will be very disappointed when they have to go and use a locking hint. So what Microsoft has got it backwards, right? Microsoft got it way backwards with the isolation levels. Rather than making people who need to do some weird fetish stuff by writing queues in databases have to use locking hints, they have put the onus of locking hints on normal people who just want their queries to finish. And what does that end up being? No lock. Everywhere. Just no lock, no lock, no lock, no lock, no lock. And that's just wrong. Because now there's just like 5 million Pavlovian response blog posts about no lock, blah, blah, dirty data, phantom reads, this, that, and the other thing. Everyone's angry about no lock. But hardly anyone who complains about no lock really presents you with a better way to get rid of your blocking problem. So Faris asks, how about forcing a loop join in one of the other queries to show why repeated seeking can be worse than hash and scans? No, it's not outside the scope. I think I could do that, but the question that I would have in that, with that demo, is how do I relate that to what's inside of an index? So that's a good thing to know about nested loops joins, but I don't know if that's a good thing to know about indexes. So if this were, if I wanted to deep dive onto indexing for join performance, and I wanted to jump into what are the different types of joins, what are their pros and cons, what are their weaknesses, and that would be a very good thing in there. There were a lot of demos. Actually, there were three different demos about stuff, weird things with nested loops joins that I had in here that I ended up pulling out, because at the end of the day I would look at it and be like, well, it's a great thing to know about nested loops joins, but it just doesn't pull back into the theme of indexes, right? I think that's a great idea for a demo. I just don't know how it would fit in here. Like already, like talking through this, there are a couple other demos in here that I'm like, well, that's not really all that indexy either. Like I'm gonna have to go back to the drawing board on a few of these. But on the plus side, I've been talking for over an hour now, and I'm like, we just got to the rights part of it. Now there were a lot of like sort of digressions and sort of sidebars, but it's really helping me figure out the the timing of things. I don't know. I'm gonna have to refocus a little bit. Talking through these things is always important. So what I'm going to do is, because I wrote a note to myself, a very professional note, to turn off query plans. What I'm going to do is I'm going to run this update, and I'm going to get the query plan for this update. And I'm also going to look at what locks were taken during the update. And I'm also going to roll this back. And since I am on the wonderful, fabulous, beautiful SQL Server 2019, I've got this cool thing enabled on my database called Accelerated Database Recovery, which means this rollback is going to be very fast. If you try this in real life, you might not be on SQL Server 2019. You might not have Accelerated Database Recovery enabled. Rollbacks might not be so nice for you. They might not be so kind. They might be terrible on your server. They might be that never-ending steamroller that gives you bad ideas. Might have some bad thoughts about SQL Server. So let's run this, and what we'll get back is some interesting stuff. So here's the query plan, right? And we can see that because I dropped off the indexes. In order to find vote type ID equals 4, I need to scan the entire clustered index again, right? That's what I got to do. It's what I have to do to find this data. And then I can update the data over here. Cool. Great. What does that have to do with indexes? Well, whenever we have... Can I show short? No, I have the scripts published. There's no reason for you to look at it. There's no reason for you to need to know what the code does here. The scripts will be published for it. So what's going to happen here is SQL Server is going to start taking locks. It's going to take some locks on keys, and it's going to take some intent locks on pages, but at the end of the day, it's going to take an exclusive lock on the object. SQL Server is going to be like, you know what? That's enough of that. I'm not taking any chances. We're just going to try to lock the whole thing. If I create this index on the vote type ID column, this lets us find data in the index. All right, this is going to help us find vote type ID equals 4. So this is going to change not only how SQL Server looks for data, but also the kind of locks that we take. So if we run this now, we're going to see things change a little bit. In the execution plan, we're now able to seek directly to where vote type ID equals 4. So if there's a message here, it's going to be that vote type ID equals 4 is, or rather, indexing for modification queries is just as important as indexing for your read queries. So with vote type ID equals 4 here, we're able to seek very efficiently to find all the vote type ID equals 4, and the locks change. So now we only have an intent exclusive lock on the object. We only have an intent exclusive lock on the page, and now we only have exclusive locks on the keys that we care about. Before, without that index, SQL Server started tallying up those locks and went, bye, and it decided to lock the entire object. So that's not fun. But just looking at what locks get taken probably isn't as interesting as looking at what happens with blocking. So I've got a stored procedure that generates a very specific query plan. I'm going to turn on query plans just so you can see it. It's going to give us a key lookup, right? And so here's our key lookup plan. Here's our nested loops join. Here's our key lookup. And what we're going to do next is run this store procedure. We're going to intentionally get ourselves some parameter sniffing, and we're going to run this store procedure so that it runs for a much longer time. Because SQL Server came up with this execution plan based on vote type ID equals 4. If we go dig into the plan properties a little bit, we can see from the parameter list, SQL Server was looking at this and it says, yes, we are going to compile this for 4, and we are going to run this for 4. Good for us. All right, good. We've got that figured out. Vote type ID equals 2 is going to give us a lot more back. But before I run that, I need to get a little bit set up here. Let's open up a new window. Over here, let's open up Mr. SP who is active over here. And if we run this, we're not going to get anything back, and that's just what we want. We want to make sure that absolutely nothing is happening here. And now, if we go run this store procedure, we're just going to run it for a lot longer, right? And we run this update. That update is going to be blocked behind the select. And if we keep running this lock time is just going to keep running up and running up and running up and running up. And the reason that this is happening is because this select, because of the key lookup, is going to be taking weird locks. Right? Everything over in here is going to be taking what's called a shared object lock. And if we go, and SP who is active has this really cool parameter called get locks equals 1, which will show us what locks we're taking. And if we look at the locks that select is taking, we can see that at the object level, we have this big shared lock. And that shared lock is incompatible with the type of lock that this wants to take, which is an intent exclusive lock on the object, right? This query is like, oh, I'm going to need to change that, and SQL Server is like, no, you can't change that. See, normally when you have queries that read data, they take locks and they sort of carry on immediately afterwards. They just lock, done, 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 lock, done, 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 done. They read stuff and they let go pretty quickly. Key lookups are different. And key lookups are different because what happens is, when you have data coming out of one index, which is the non-clustered index here, and you need to go find data in the clustered index down here, SQL Server will take that big shared object lock and not allow modifications on the clustered index, because if data changes here, then data will be inconsistent here, right? Anything that we find here really does have to match what's going on here for the duration. So this query ends up running for 22 seconds with the parameter sniffing issue, but you can kind of get a feel for if you've ever seen something really weird happen out in the wild with SQL Server. Ever seen like a select query at the top of a blocking chain? I can guarantee you that there was a key lookup in that plan. And of course, that's like a pretty exacerbated. That's like I intentionally made that really, really bad. I'm not saying that can happen. They'll absolutely happen to you too. They can absolutely end up being that bad for you too. But where things get more interesting is with deadlocks. So let's reuse a couple windows here. These are both done. So what I'm going to do is stick a couple different queries into these windows. One of them is going to be responsible for updating the votes table, and one of them is going to be responsible for selecting from the votes table. So we're going to replace these. Oops, it's focused in on the wrong part. Always seems to happen. So I'm going to run this one, and I'm going to run this one, and eventually we will end up with a deadlock, I hope. At least it was working before. If it doesn't work now, I don't know. I think I'm cursed. Something has cursed my presentation. Of course, it happened a lot faster before, too, so who knows? Maybe it is cursed. Oh, man. I am cursed. Forrest, I blame you. Let's see. Was there some... maybe I needed to reset this. Maybe that'll do it. I should put that up at the front. All right. Try that again. I might be back to the drawing board on this one. Who knows? This deadlock was working wonderfully before. No, I don't turn that on. No, I have a demo failure. Wah, wah, wah. No, everything should be cool here. All right. I'm not exactly sure what's happening here. Let me step back a little bit. Let me drop indexes. So we only had that one. Kill a black root. I might have to. Too many of my demos rely on killing roosters. I'm starting to feel kind of bad about it. So let's see. What's going wrong here? Oh, that poor rooster. Yeah, that should be that. And we should be getting... So let's take a closer look. Let's do a minute of troubleshooting. Let's look at the execution plan we're getting here. Yeah, that's doing what we want. We've got the cluster index seek. Let's look at what's going on here. Ah, that's what it was. Interesting. Interesting. So what's changed here is that SQL Server is not using the key lookup plan that I wanted. So what I'm going to do, I'm going to force the issue a little bit. Index equals Erica Badu. And now, watch what's going to happen. We're going to get a different execution plan. Oops, I didn't even get one that time. There we go. So now we're going to get the key lookup plan that I wanted. I'm going to have to go back and figure out exactly what happened there. See, it's very strange that that would happen. I wonder what I did wrong. I must have. Oh, you know what I think I did? Now I remember. Aha. Okay. Now it makes more sense. All right. So the boring explanation is that I think I was messing around with this query a little bit, and this should be looking for a vote type ID. And the reason why it went back to using the primary key cluster is because I'm searching on ID now. So this was that's what I did. I fudged something up when I was walking through and messing with stuff. So now I'm gonna have to change that query back to the way it was. Oops, you know what I should do is not turn on, I should not have query plans turned on when I'm running things in a loop. First rule of performance tuning. If you have a loop, don't use query plans turned on in it. Nothing good will come of that. In fact, I have to cancel this thing before SSMS does its best impression of a black rooster. So let's run that update. Why are you still turned on? You sick bastard. Yes. All right, there we go, there we go. Now we should see that deadlock. If we don't, I'm just going to move on. There we go. Beautiful. Wonderful. See, we got a deadlock. We got the deadlock that we are after. Good stuff. All right, so this read query ended up deadlocking with this update query. And that, again, happened because of the key lookup. I'm going to flip execution plans back on one more time just so I can show you or try to explain exactly why this happens. So in real life, in like normal life, when you have a deadlock, it's usually because like tables get accessed in a different order, right? Like the classic deadlock scenario is like, someone runs begin tran, table A, table B, table A, table B, right? Like table A and table B kind of crisscross in the update path. But what happens with key lookups is something kind of similar. So the query plan for this is going to be like one side of that backwards path where we scan this index, right? We scan the non-clustered index, we find all the data we want, and we quickly release those locks. But on the lookup side, we're holding that object level lock. SQL Server is not going to let go of this until the query finishes. But over on this side, we're doing things in a backwards order. Over on this side, we're reading data from the clustered index, and then we need to update the clustered index. And SQL Server wants locks here too. So because we're doing, we read from the clustered index and then try to update it. And in this one, we read from a non-clustered index and then try to read from the clustered index. Because we're doing things in sort of weird backwards order, we end up with that deadlock. So so like where everyone talks about how read queries, this, what problem could we possibly have? Everything's fine. Like just reads, and no, just don't worry about it. Reads can totally block writes, and reads can totally deadlock with writes. So of course, fixing it is just a matter of getting rid of that key lookup, right? So if we stick post ID into the key of our index, right? We have post ID alive and kicking in here. We can avoid that deadlock altogether. I mean, actually, things will finish a lot faster on both sides, but it's. I guess that's not really the point. Isn't really speed so much. The point is that we don't have deadlocks anymore, which is really important, right? You know why? Because you know what I hate troubleshooting? Deadlocks. Because it's always something like this. And the deadlock XML, as helpful as it is, you don't get that query plan in there. So whenever you see like a read query inside of like deadlock XML, you just kind of have to infer that there's a key lookup in there. So I'm going to turn execution plans back off for these. And we will amazingly see this query, or both of these queries, finish to completion pretty quickly with that index change, right? So, changing indexes to help fix key lookup can be a really helpful thing for performance, because performance isn't, to me, performance is not just about having queries finished quickly. Performance to me is also about not having to deal with deadlocks, right? Because queries that error out because of deadlocks, it's not fun, right? Not a good time. It's not my favorite thing in the world. So we had no deadlocks there. The updates all finished. Everything was happy. Everything is normal. But yeah. So I apologize for the little demo issue there. I wonder when it was that I changed. I'm gonna have to go back and double check that because this should definitely be. Where vote type ID equals 4, I think. So I have to go back and fix that. Maybe I'm going to make a note to myself here. This is the select query where vote type ID equals 4. Thank you to the nice folks at Redgate for letting me pay for a copy of SQL Prompt. Hopefully, if I say SQL Prompt out loud 3 times, then they will SQL Prompt me for free. Maybe someday. So. Kind of interesting stuff that can happen with lock escalation too. Now this is another one of those demos where I'm like, I like it, but do I need it forever? How much do I love it? Right? Does it bring me joy? So what I'm going to do is update this table again. Now, this is the votes table again. This is just the plain old votes table, and right now we only have this one index on vote type ID and post type ID. Now keep in mind we're updating user ID. Right? So user ID isn't in this index, this non-clustered index. So we don't actually have to touch that, but we do have to touch the primary key, and we do end up taking a whole bunch of key locks in order to update that. Because while we can use this lovely Erica Badu index to find all the values for vote type ID, right? Where vote type ID equals 4, we cannot we don't have to also update this index in order to change user ID. We only have to update the clustered index for that. All right, so fun stuff there. What I have is a different table. And I have this different table because really I don't want you to sit here while I create 10 indexes on the votes table. It's not fun. It's not interesting. It's not exciting. I just don't feel like killing that much time. So what I'm going to do is I'm going to use this other table called votes_beater, and I call it this because I just beat the crap out of it. I only use it for these write demonstrations. I don't use it for anything else. It's just kind of there as a sort of a kicker. It's like if I don't know how many of you have like multiple cars, but if you have that like one crappy car that like I don't know, maybe you're saving for like your kids to drive one day, or that you drive when like things are particularly gross. I don't have any cars. I'm not like speaking from a position of knowledge here, but just like the closest thing I can think of is like that car that you would give your kids one day. That thing that's already beat to crap that they can't possibly do any more damage to. So I'm gonna run this query, and with a very clear predicate on vote type ID equals 4. We're going to take a whole bunch of locks across a whole bunch of indexes, right? But notice what we get here. We have exclusive locks. You have 2 feet. Does that count? I don't know. Do you only walk on 1 foot when it's rainy? Or do you like only put on 1 good shoe? Do you have a beater shoe that you wear and hop on through mud puddles? I don't know. But you see we have a whole bunch of intent locks on objects and pages. There's 1 intent exclusive lock up here, and then we have a whole bunch of exclusive locks, but they're all on keys, right? All the rows where we have exclusive locks are all on keys, and that's because we wrote a perfectly nice, perfectly good query for SQL Server to find vote type ID equals 4. But we can do things that mess this up too. Right? We can do things that make this painful for SQL Server. So what we're going to do is declare a variable. Right? We're going to use this terrible, awful local variable thing. And this is the demo that I'm talking about, where I like it because I think it's interesting, but I don't know how much I don't know how much this tells you about indexes. Aside from the fact that you writing bad queries can be harder on your indexes, which is like maybe a good point. I think it's a good point to get across, but I don't know that it's like. I don't know. I don't know if this is gonna make it. You might be the only people who ever see me do this demo. I don't know yet. But if we run this, and we're gonna declare a variable here. We're gonna use that local variable down here in our where clause. Run this, and we are going to get quite different locking. So rather than rather than getting a bunch of locks on keys, now all our exclusive locks are on pages. So we've switched from locking just the keys we needed to SQL Server being like, uh-oh, I don't really know what I'm gonna have to do. I'm gonna start locking pages. I'm just gonna so like rather than just like having like a narrower set of locks on keys that we're interested in, we've now locked entire pages that like might have like totally innocent values on them. Right? We might have pages with vote type ID equals like 3 or 5 on them. And it's like they have nothing to do with vote type ID equals 4, but darn it, those pages are locked down anyway. This is another kind of weird blocking problem that we can run into. So what I want to point out, though, is that blocking is not really affected by parameter sniffing. So let's drop clean buffers and let's free the proc cache. I want to start with a totally clean slate here. I want absolutely nothing going on prior to running this, right? And what I'm going to do is I'm going to use, rather than like just write a simple SQL statement with the vote type ID declared up here, I'm going to pass that variable into some dynamic SQL down here, right? So I'm going to use dynamic SQL to my advantage, and this is the the unhackable dynamic SQL, right? This is the kind that's like parameterized so that no one can SQL inject me, because I hate getting SQL injected. It's very painful. It happened once. I'm still sore from it. I'm going to run this, and I'm going to run it for vote type ID equals 4 first, and that's going to finish pretty quickly. We're going to get an execution plan back, and you can see in the execution plan that we really do update all of those indexes. We really do hit all of them, and we're able to again seek into at least one of our indexes to find the rows that we care about. So like this thing is going to guess 2400 rows, right? And based on the 2400 row guess, we are going to take a bunch of key locks, because SQL Server is like, you know what, we can start locking the keys. Totally fine, not a big deal. I'm okay with this. But if we have to, we can start locking the object. Now, just because we're talking about locking, I want to make sure that everyone kind of understands, is SQL Server has to take intent exclusive locks kind of like from biggest to smallest. So we have to start taking an intent exclusive lock at the object level. This doesn't mean that the object is locked. This means that SQL Server intends to lock something near, around, by, somewhere close to the index. And then the same thing for pages, because pages are sort of a bigger lock than keys, right? So when we're locking pages, SQL Server is like, I need to lock I don't know if I'm going to need to lock the page or the row. I don't know that yet. But we have to take those locks all the way down. But then we end up with these, like the only exclusive locks are on keys. Cool. And remember that we have a guess of 2400 rows here. Let's change this to 12. And let's rerun this. Now, rerunning this is going to give us a parameter sniffing situation, right? Rerunning this with vote type ID equals 12 is going to mean that SQL Server is going to reuse the plan for 4, and it's going to preserve the cardinality estimate for 4. So let's go ahead and run this. And now we're going to see that we just get one object lock. But even though SQL Server guessed that 2400 rows were coming out of there, as soon as that started ticking up, SQL Server said, no more, get on up. Now let's actually do something interesting, and let's do that backwards. So let's start with 12. All right, let's start with the big one. No one ever tells you about the begin tran, right? So let's run that one. So we get the object lock there, and let's see what happens when we switch back to 4. Right. So pretty interesting, right? So when the way that it started off was SQL Server did not care. It took a whole bunch of key locks for the small one. It took an object lock for the big one. And it just kind of used what it thought was right situationally, right? So parameter sniffing didn't mess with this. When SQL Server thought that 2400 rows were going to come out, it still escalated to the table level lock when it got more. And when SQL Server guessed that 9700 rows were going to come out, it still only used the smaller level locks when we reuse the plan for this one, right? So like parameter sniffing doesn't really mess with locking all that much. Like locking is kind of its own beast. Imagine if locks were something else that were like sensitive to parameter sniffing, the world would end. No one would use databases. Everyone would go use MongoDB. So this is sort of the last of the demos that I have. The real problem with having lots of indexes on tables. Now remember, So this votes beater table, right? The votes table that I only use to sort of take abuse from these rights. This has 10 indexes on it. 1, 2, 3. They're all named by the number 4, 5, 6, 7, 8, 9, 10. We have 10 full indexes on this table. Normally when I'm working with people and, we'll go and run SP Blitz index together, we'll hit F5, the script will run, we'll start looking through indexes. One of the first things that I always try to do before I tell people, you need to add these indexes, is look at indexes that might not be all that helpful. So I might start looking at unused indexes, I might start looking at indexes that have way more writes than reads, and I might also start looking at, indexes that have like very close by definitions that maybe we could turn like 3 indexes into 1 index or something, right? And the reason that I do that is because SQL Server has this thing called the buffer pool. And the buffer pool is where SQL Server stores data that it needs to work with. And a lot of people are under this weird impression that, you read data in there and it stays there, and it might get run out eventually. But what's really messed up is that when you have you have indexes that aren't used by queries that need to read data. So in other words, unused indexes, or maybe they have way more writes than reads. Maybe they're just not heavily used. Or if you have indexes that are very close by in definition, and SQL Server sometimes uses one, sometimes uses the other. But all those indexes, when you put data into the table, they need to be maintained at the same time, right? If we go back and look at this execution plan, every single index 1 through 10 is in this execution plan. Every single one of these indexes is getting touched. And of course, the real problem with having lots of indexes that might not be used, that might not be, like the best index to have around, that might be duplicative, that, just all sorts of things about them. The real problem with those indexes is that even if they're not used by read queries, we still need to get them up into memory before we modify pages in them. So I've got a couple other helper views here. And I've got a blog post coming up where I'm going to publish all these scripts. If you want to see them now, let me get over and grab the link for you. Let me see here. I spelled GitHub wrong. GitHub.com. And I will give you a link to my helper views and functions that I'm using today. Oh, you got that. So if you stuck around to the end, you get that. Everyone gets that. So those are the helper views. What's up memory? What's up indexes? What's up blocks? All those things are in there. The real problem with all those unused indexes is that they end up in memory when we need to write to them. So this view here will tell us what indexes are in memory and how much space they're taking up in there. And notice that we've never run a read query against this votes beater table. Every query that we've run against votes beater has been an update. We haven't done a single thing to this table that said select from votes beater. But what happens is when we need to modify those pages, they need to end up in memory. Not every single page from every single index goes up there, but we got a pretty good chunk of them, right? See all the stuff in here? Like there's a pretty decent chunk of these indexes that end up in there so we can modify stuff. And all 10 of those indexes will have stuff that ends up in memory. I know from looking at your servers, you don't have a ton of you have way too many indexes on your tables as is, right? Let's see here. I use SP Blitz Index to help tune indexes. One issue I run into is that I haven't had a chance to resolve yet. Removing unused indexing. We have a replicated instance. Index usage stats don't survive across replication like that. You only get the local. I posted a link before you changed it. That's funny. Unfortunately, index usage stats aren't preserved like that. So Yeah, I wish there was a better way to do it. I wish that, um, you know, I wish that was like something you could change, but unfortunately, that's just it's just not the way SQL Server works. But then I think a lot of the things that have been things that I don't like are related to the way SQL Server works. You need to compare the underused recommendations to find where it's not. Ah, yeah, that's a tough one. Yeah, because Mode 2 only writes out to a table right now. So I guess what you could do is I don't know how deeply you use the first responder kit scripts, but you can use SP Blitz first to log the results of SP Blitz index to tables. It might be, I don't know, like depending on if you're stronger with SQL or with Excel or whatever you find might be easier. If you log both of those to tables, it might be a little bit easier to write a query to compare them than it would be to use Excel to compare them. But yeah, that's a painful thing, and that's not only painful for people who use replication, people who use log shipping, mirroring, availability groups. People who use any of that stuff. It's all wacky. It's all very wacky. He says, so true about having too many indexes. I've recently started collecting data in order to remove ones I can. 19, wow, most of which have almost every field it includes. Yay! Someone listened to, how many of those indexes have DTA in the name? That's my question. Just wanted to make sure there wasn't a simple solution I didn't know about. No, unfortunately, that's not something that's so simple. That's something that bites a lot of people who use availability groups. And then, I think it's a real sort of shortcoming of availability groups too, is that, like with replication, at least with some kinds of it, you can run like a post, data movement script, and you can create different indexes on a replicated copy of the data, which is awesome, right? You can create different index. You can say, hey, I want a different index over here because I'm running different queries over here. But if you have a readable secondary in an AG, you're screwed. If you want an index on the secondary, you have to create it on the primary. And forget about how painful creating indexes on an AG primary can be. Now you have this index in both places. You might never use that index on the AG primary, but now it's there. It's like, if you wonder why people are slow to adopt features. It's because a lot of the stuff that's like very V1 just never ends up getting resolved. So it's just like, yeah, we got this brand new thing, use it. And it's like, wait a minute, I can't use that. That would suck in every conceivable way. I understand the problem it solves, but it would just create 40 other problems. I think I would have an easier time writing my own version of replication than using an AG sometimes. It's nuts. It's bonkers. It's crazy. It's insane. So I guess that was kind of it for the demos here. And we talked about that. That's the end. The only thing left after this is the cleanup, which you probably don't care about. Nothing too interesting in there. But yeah, so I thank you everyone for coming. I'll let y'all, if you want, over in chat, ask some questions. If you have any SQL Server stuff you want to talk about, you can absolutely do that. But thank you for coming. It was very helpful to be able to sort of talk through these demos, just try to get an idea of things that I want to keep, things that work, things that don't work. It's always nice to have a little bit of an audience to kind of help you with these things. Otherwise, it's very hard for me to sit down and talk through this stuff out loud to myself and be honest with myself about it, because I'm like, oh yeah, this is going to be fun, and then I start reading through things and I'm like, maybe not so much. So I appreciate it. So that's all I had for working through the presentation. If anyone has questions, comments, concerns, things you like, things you didn't like, chat's totally open. You can ask SQL Server questions. You can talk about the presentation, whatever you want. The presentation schema is, I talked about this way at the beginning. The presentation schema is this database called Stack Internals. And it's a database that I recently created. and the whole point of it is just for this demo. It's a very, very small database. I took their most recent Stack Overflow 2019 copy, and what I did was I took only the data from 2019 on, rather than taking the data from like only 2008 to 2010 or something. And I just did it because that was a good chunk of data, and it was all sort of like, nice and homogenized and all that stuff. So it was a nice chunk of data, but it wasn't like, it wasn't too big. I can create indexes quickly. I can get rid of them pretty quickly. So it was just sort of a small data set to use for this. I don't know if I'm ready to distribute it yet. I just started today distributing sort of a chopped down copy of the Stack Overflow 2019 database without a couple of the bigger tables in it. That was in today's blog post. Let me go get a link for y'all nice people real quick. I really need to work on my my link to chat time. I don't know how I can get better at that. Ronald says, "You're almost Brent. Thanks." My mom calls me Brent sometimes. He says, "Thanks to the stream. Brent and Eric streaming is a sign of things to come." I don't know. I would happily live stream with Brent if Brent wanted to live stream, but who knows? Oh, presentation on YouTube. I am in Holland. What is the presentation schema? I'm sorry, I don't understand then. I joined really late, last 15-20 minutes, caught the tail end of the conversation about deadlocks. The focus of the presentation around concurrency locking, implications around indexing. The first thing that I cover is how indexes help with read performance. What exactly it is about indexes that make queries perform better when they exist, stuff like that. And then the second half moves into stuff about writes and concurrency and things like that. So sort of a mix of both, because I see a fair amount of people who have problems in both areas, both with select queries that either don't have a good index, or just don't have any indexing at all, or then on the flip side, it's like we've got terrible locking and blocking problems. And curiously, they are both things that can often be solved with right indexes. Let's see. Here's a question with multiple fields in the select statement, commas at the end or the beginning of the fields. I always go with commas at the end. I realize the wisdom in sometimes putting them at the beginning if you need to switch things in and out. But, I don't really care either way. I use SQL prompt, so that puts commas at the end for me. But you can totally use SQL prompt to put them at the beginning too. When start my life presentation? 1980. November of 1980 was when I was born. Thank you for asking, Ronald. Lee says, "I'm shocked how harsh Brent is on his streams. He does get some crazy questions, however, so I guess it makes sense." Yeah, I understand. Sometimes, but when you put enough out there in public and you get enough weird feedback on it, some days you're just like, I wish I didn't put that in public. Lee says, "We're the same age. I know it's hard to believe, Lee, that someone who looks like they're 55 could be the same age as you." I guess the biggest thing is if you come unprepared for something, I'll call you. Yes, well, that makes sense. That makes sense. That makes total sense. Because I don't like unprepared people either, which means I hate myself. All right. We got any other questions? Lee, you're always good for a question or two. Do you have anything you want to get out there? Anyone out there listening? So here's an interesting question that came in via email. Could you please send me the recording? Let's see. No, but you can see it on Twitch or YouTube when the broadcast ends. It'll go up automatically. Thanks. There we go. All right. Good, good, good. Thankfully. Sorry, not prepared for questions. Just listening patiently. All right. So it's been like almost 2 hours, and I'm gonna get going. Thank you all for coming, watching. I'm going to use what I learned today to polish up this presentation. I think I'm gonna nix some of the demos, and I'm going to I think I'm gonna have to add in some new ones where I'm gonna have to add in some new ones to sort of make up for it, maybe. Or maybe I can just refocus this whole thing. Almost 2 hours. Bleb stream. I don't know what bleb stream means. Bleb is a dog thing. He says, how do you constantly find topics to blog about? You know, sometimes it is a lot easier than others, I'll tell you. You know, then this is something that I haven't really, like, I don't want to talk about it like a lot, because it's not really something I want to like dwell on, or something that I think anyone's going to find interesting. But, you know, it's from like, when we first went into lockdown, I was like, man, I'm going to have all this time. I can't go to the gym. I can't really leave the house to do much. I'm not going to be like, you know, going out to eat. You know, all the family stuff is like in the next room. I'm going to have like nothing to do. I'm going to have so much time on my hands. And, you know, like a month into it, I hit the wall so hard. Like, I don't really have a word for like mentally what happened, but like I don't know if it was like burnout or like what it was, but it was just like I had nothing for like forever, and you know, it took a long time for that writer's block to sort of wear off. But you know, there are times when like I'll get into a topic, and or like, you know, there will be like a few different things that I want to write about, or the things that I run into with clients, and I'm like, man, I could write 40 blog posts about this, and like it's great, and like, you know, you have that like feast of things. But you know, I think, you know, part of it is like, you know, writing about what's in front of you, and you know, just kind of having the, I don't know, courage or audacity or whatever you want to call it, to think that whatever you're looking at might be interesting to someone else. Sometimes it's true, sometimes it's not. You know, I have plenty of dud blog posts, and I'm like, this is going to be so cool to someone, and then it's like crickets. And then I'll write some blog posts, and I'm like, I just need something to fill up the queue, get out there, and then it's just like, boom, like retweets and comments. It's like, yeah, there's like electric guitars playing. So it, you know, just write. Just, you know, whatever you're working on, whatever you're looking at, I guess just write about it. You know, even if you know, hit some weird logical stopping point and just save it as a draft. It's helpful to just have it there, and maybe you come back to it. You know, maybe you can expand on it. Maybe you you know, find something just totally utterly wrong with it later. You know, whatever it is. Swaglow, you're welcome. Let's see. Go back a little bit. If SQL Server suggests an index with many includes, the best to just ignore. Yeah, so whenever I see a lot of included columns in an index and a missing index request, you know, my first inclination is to create just the key columns. Not that SQL Server can't suggest a lot of key columns in a missing index request, but I really like. But the included columns particularly, yeah, like my first inclination would be to just create the key columns and see how it gets used. You know, like we talked about today, key lookups do have some downsides, especially if queries don't run so fast, or if you start running into deadlocks. But, you know, those are admittedly sort of oddball scenarios, and, you know, they're good to know about, but you might just beat the clock if you get the key columns in. But, you know, just remember that with missing index requests, the big thing about it is that the index columns, and let me actually go grab the Stack Exchange Q&A about it. The big thing about the missing index request key columns is that they are not in a terribly thoughtful order. They are just in sort of table ordinal position order, and there's a Q&A about it over on Stack Exchange. There we go. Let me drop that in. So yeah, so that's, they do work sort of strangely. They are, to me, missing index requests are sort of like a crying baby. You hear the crying, you realize that something has to be done, but it's up to you as the adult to figure out exactly what that is, right? Like that, like that baby's crying. You don't really know why it's buying. Like, you don't know why that baby's crying. You don't know. Like, it could be a dirty diaper. It could be hungry. It could be tired. It could have gotten a scraped knee or something. It could have there's any number of things, right? It's up to you to go figure out why that baby's crying. Sometimes babies cry for no reason too. Like, there's lots of times when I'll be coming up with demos, and SQL Server will ask for an index request on a part of the query that takes no time whatsoever. So I'll give you actually kind of an interesting example. So let's drop off let's spell things right. Let's drop off indexes here, and let's dbcc. Ooh, boy, oh boy. Mavis Beacon never use SQL Server. So let's drop clean buffers, and let's say select count from users join post on p dot owner user id equals u dot id, where u dot reputation is greater than 100,000. All right, so we have this query now. We turn on query plans, and we look at what happens in this query. We get 0 rows back. So this is actually not a good example because we don't have many high reputation users in here. So let's backstep a little bit. So this is part of the fun of A, live demos, and B, writing demo queries in general. So we'll just say greater than 1 this time, and we should actually get some results back on this one. There we go. There we go. Now we're cooking. Right. So, but SQL Server now doesn't ask for a missing index. My luck. Yay. So, let's see. Maybe we can do this. Maybe this will get us where we need to go. I bet this will get us going where we need to go. All right, so we'll make sure those are adios, and let's get an estimated plan this time. Okay, cool. Wait, it did it backwards. Wow, SQL Server is outsmarting me today. I'm not going to waste your time anymore. But there are a lot of times when I'm writing a demo query where SQL Server will ask for a missing index on part of the query that just, didn't really do anything, wasn't really didn't really take any time, and you're just like, well, what does adding that index really improve? What do we really get here? And that's sort of the funky thing about them. Yes, it is all ordinal position. Well, I mean, it's not 100% ordinal position. It's it does start with equality predicates, and then it does move on to inequality predicates. But within both of those groups, it really is only ordinal position, which is, kind of a shame. All right. So looks like attendance is starting to drop off a little bit, and there hasn't been any questions in a few. So I'm going to get going. Thank you all for joining me. I appreciate it. I am going to press a button on my Stream Deck here, and I'm going to hope that this button actually takes me off air. So we're gonna try it out and see what happens. Cardio. Wait, did it work? I don't know.